Okay, welcome to this video on Year 1 Pure Chapter 2 Prep Practice Test Answers. So if we look at the first question, this is solving a quadratic using the quadratic formula. So the quadratic formula just put it here, is x squared minus 4x plus 3 is a quadratic, and the formula is x equals minus b plus or minus the square root of b squared minus 4ac all over 2a. And so for this quadratic, we have that the coefficient of x squared is 1, so a is 1. The coefficient of x is minus 4, so b is minus 4. And the constant c is 3. So substituting into the formula, b being minus 4 means that minus b is 4. And then minus b squared is minus 4 squared, which is 16. And then a and c are 1 and 3, giving us 4ac as being 4 times 1 times 3. And so we get that x is 4 plus or minus the square root of 16 minus 12 over 2 times 1, which is 2. And simplifying that, we get 4 plus or minus the square root of 4 over 2, which is 2 plus or minus, which is 4 plus or minus 2 over 2. And 4 over 2 is 2, and 2 over 2 is 1. So we get 2 plus or minus 1, which is 1 or 3. Okay, so that's question 1. Question 2, it's the same quadratic, but this time we're going to be doing by factorization. And so if you write down brackets, we can see that the x squared is going to be obtained by writing an x in one bracket and an x in the other bracket. And then the plus 3 is going to be obtained by multiplying two numbers together. They could be plus 1 and plus 3, or minus 1 and minus 3. But in this case, if we want to produce minus 4x, when we multiply this number by the x and this number by that x, it's going to need to be minus 1 and minus 3. So we have the factorization becomes x minus 1 times x minus 3 equals 0. And now to get the solutions from that, the only way that a product is equal to 0 is if one of the factors is equal to 0. So that means that either x minus 1 is 0 or x minus 3 is 0, which leads us to x equals 1 or x equals 3. Please avoid shortcuts like saying we just change the sign around, because we'll see later that could have more complicated things in here, and you really want to get into the idea that the solutions are what makes this bracket 0 or makes that bracket 0. And so you then simply solve that. X minus 1 is 0 means that x equals 1. But if you had something like 2x plus 3 equals 0, then it wouldn't be that x is minus 3. You'd have to rearrange 2x plus 3 equals 0 to be x is minus 3 over 2. So keep that in mind. So again, we get the solutions that x equals 1 and x equals 3, as we saw before. Now completing the square, we have that x squared minus 4x can be written as x minus 2 squared. But x minus 2 squared produces the x squared minus 4x, but it also produces a plus 4. So that means that we replace x squared minus 4x by x minus 2 squared minus 4. And so the minus 4 plus a 3 gives us a minus 1 here. And you should really check this out. You should multiply that out and check that it gives us what we want. So multiplying out the x minus 2 squared, we get x squared minus 4x plus 4. And then if we subtract 1, we get the plus 3 that we want. And now rearranging, because x is now in only one place, we move the 1 to the other side. We get x minus 2 squared equals 1. Taking the positive and negative square root of both sides, we get x minus 2 is plus or minus 1. And then adding 2 to both sides, we get that x is 2 plus or minus 1, which again gives us the 1 or the 3. So all three methods give us the same solutions, of course. But we should really know how to use the formula, we should know how to use factorization, and we should know how to complete the square. Okay, within the formula, the bit that is called the discriminant is this bit here. So if you have this formula, this b squared minus 4ac is the bit that discriminates what solutions we have, whether we have one solution, two solutions, or no solutions. And so if we look at this example here, x squared minus 4, x squared plus 6x plus 10 equals 0, we can see that a is 1, b is 6, and c is 10. And then if we calculate the discriminant, the bit inside the formula that is inside the square root, so that has a symbol of a triangle, that equals b squared minus 4ac. So b is 6, so b squared is 36, minus 4 times a is 1, and c is 10, gives us 36 minus 40 is minus 4. That basically tells us that this quadratic, there's no point in trying to use the formula or factorize or completing the square. If we do any of those, we find that it has no real solutions. And that is because we would end up with a square root of minus 4. And the square root of minus 4 has no real solutions. It has complex solutions, things involving I, but for the A-level syllabus, as far as we're concerned, it has no solutions. But more properly, we say no real solutions, just in case people study complex numbers to be slightly more correct than simply saying no solutions. Question 5. We now want to express this in this form, that is completed square form, and it has a number in front of the x squared, which makes things a bit harder. So to get into completed squared form, what I suggest you do is you don't worry about the 35, only look at the 2x squared minus 16x, and then factorize out the 2, which gives us 2 times x squared minus 8x. I'm focusing only on that. If we complete the square on that, we write x squared minus 8x as x minus 4 squared. But x minus 4 squared produces x squared minus 8x, but it also produces a plus 16. So we need to subtract 16 to make sure that this whole expression here is the same as x squared minus 8x. And we still have a plus 35 outside. Now if you multiply out without expanding the x minus 4 squared, we get 2 times the square, gives us 2 times x minus 4 squared, and 2 times the minus 16 gives us minus 32. So be careful, very easy to miss that, the 2 times minus 16. And then we also have plus 35, minus 32 plus 35 is plus 3. And so we get this. You should really multiply this out. So take x minus 4 squared, multiply by 2, add 3, and you should get the original expression of 2x squared minus 16x plus 35. And then we can use that completed square form to do all kinds of things, including finding the minimum or maximum and where it occurs. And that's what question 6 is about. So for this question here, we have exactly the same quadratic, and now we're asked to find the minimum value and the value which that occurs. Well, if we look at the expression that we have here, and if I just get a different highlighter. So here, okay, that bit there. Can you see that just this bit here, that bit is always going to be positive or 0, okay? So that bit is just greater than or equal to 0. And when is it equal to 0? It's equal to 0 when x is 4. So this has a minimum of 0, and it occurs when x equals 4. So the whole thing, when we add 3, is going to be greater than or equal to 3, and it will be equal to 3 at x equals minus, at x equals 4, because that x equals 4 makes the bracket 0. Okay, so what's the minimum value of f of x? The minimum value of f of x is the value that we get when we feed in 4, so it is 3. And when does it occur? It occurs when x is 4. So it occurs at x equals 4. Okay, so I hope that is understandable, a very common question in an exam. Okay, now we're going to be looking at parabolas, and quite often you're expected to, from a known equation, to be able to draw the parabola. But sometimes you're expected to do it backwards. So given the drawn parabola, you're expected to be able to get the equation. Now here, because we know the roots, 2 places where the curve crosses the x-axis, they are 2 and 5, we should be able to see that y can be written as something, okay, times x minus 2 times x minus 5. And just to check that, can you see that when x is 2, y is 0, and when x is 5, y is 0, which means that we are there and there, that y is 0 when x is 2 or when x is 5. Now, we don't know what k is, but for a start, we know that k has to be negative because this parabola is a frowny, okay, it's upside down, and so we're going to get a minus x squared. So the a is going to be negative. In this case, the k is going to be negative, okay? But what is k going to be? Well, the thing to do is to use this value here, where it crosses the y-axis. Where does something cross the y-axis? We cross the y-axis when x equals 0. And we know that when x equals 0, y has to be minus 20. So if we substitute into this equation y being minus 20, feed in for x, we feed in 0, and work this out, we get that minus 20 equals k times minus 2 times minus 5, which is going to be plus 10k, which means that k is minus 2. And so we get that y is minus 2 times x minus 2 times x minus 5. And if we multiply that out, we get this expression here. And if you check the sketch of this, you should see it goes through x is 2, x is 5, and y is minus 20. So please do that. And at the end, because it's a more normal skill, work through it in the usual way to sketch it and see that it corresponds. Now we have for question 8, state the line of symmetry of this completed square form. Now from the argument we had in question 7, we can see that the turning point of this will be when x is 2, they will have a minimum of minus 12. Yes, so that bit there. And because parabolas are symmetrical, and it will be symmetrical about the line of symmetry, of course, but that line of symmetry goes through the minimum point. Okay, so if the minimum point has coordinates 2 minus 12, the x equals 2 is going to be the line that goes through the coordinate x is 2. And so if the turning point is 2 minus 12, then the line of symmetry will just be x equals 2. Okay, I hope that helps to understand these answers.